For residents of Ufa, water was something ordinary and familiar. It flowed from taps every day, used for drinking, cooking, washing, and countless small routines that rarely drew attention. Like in many large Soviet cities, the system supplying this water operated quietly in the background, noticed only when something went wrong. Ufa relied on nearby rivers as its primary source of household and drinking water. Among them was the Ufa River, a large and steady waterway that supported both industry and everyday life. Water intake facilities along the river ensured a continuous supply for a city with a growing population. This system had been in place for years. Its operation was considered stable and predictable. The idea that water itself could become a threat was not something people regularly considered. Once it passed through treatment facilities, it was assumed to be safe. Trust in infrastructure was part of daily life, reinforced by routine and long-term use. Upstream from the city, industrial enterprises operated alongside the river network. One of them was Ufa Kim Prom, a large chemical production facility. Like many plants of its time, it handled substances that required careful control and precise technological processes. Among these substances was phenol. Phenol was widely used in chemical manufacturing. It played a role in producing plastics, resins, and other industrial materials. Under controlled conditions, it was manageable. Outside those conditions, it posed serious risks, especially when released into the environment. Near the plant flowed a small river called Shugurovka. On its own, it attracted little attention. It was narrow, local, and largely unnoticed by most residents of the city. What mattered was where it led. Shugurovka flowed directly into the Ufa River, becoming part of the same water system that supplied the city. This connection was well known to engineers and planners, but rarely thought about by the general public. For most people, rivers were simply part of the landscape, separate from the water that came out of a tap. In early 1989, all of these elements were in place. An industrial plant operating as usual, a river system supporting the city, and a population going about its daily routines. There were no visible signs of danger, no warnings, no interruptions in supply. Water continued to flow as it always had, clear, familiar, and trusted. What followed was not sudden or dramatic. It began quietly, within an industrial process, and moved outward through the very system people depended on most. The incident began at the chemical facility Ufa Kim Prom, located upstream from the city. By 1989, the plant had been operating for decades and was deeply integrated into the industrial infrastructure of the region. Its processes involved large volumes of chemical substances that required careful handling, storage, and disposal. One of these substances was phenol. Phenol was not an exotic or experimental compound. It was a standard industrial chemical used in the production of plastics, resins, and synthetic materials. Under normal conditions, its use was regulated by technological procedures designed to prevent environmental release. These procedures relied on functioning equipment, controlled flows, and constant monitoring. During a technological malfunction, a significant amount of phenol-containing waste entered the plant's wastewater system. Instead of being fully neutralized or contained, it moved beyond internal processing stages and was discharged into the environment. The release did not occur as a single dramatic event. There was no explosion and no immediate external sign of failure. The process unfolded through routine channels, following paths already built into the system. The contaminated wastewater entered the small river Shugurovka, which flowed past the industrial area. At this stage, the scale of the problem was not visually obvious. Phenol dissolves easily in water and does not create immediate, visible pollution. The river's surface did not change in a way that would draw attention. As the water continued downstream, it carried the contamination with it. Shugurovka fed directly into the Ufa River, a major water source for the city of Ufa. This connection transformed a localized industrial failure into a city-scale issue. Once the phenol entered the larger river, it became part of the same flow used for municipal water intake. At the southern water intake facilities, water was being drawn, treated, and distributed according to normal schedules. Initial treatment processes were not designed to handle such high concentrations of phenol. As a result, contaminated water passed through the system before the scale of the problem was fully understood. Measurements later showed that phenol concentrations in the area of the southern water intake exceeded permissible levels by more than 100 times. At these levels, phenol could not be ignored or diluted away. Its presence affected both the chemical composition of the water and its sensory qualities. Residents were among the first to notice something unusual. Tap water developed a strong, sharp odor and an unpleasant taste. For many people, this was the first indication that something was wrong. Unlike air pollution, which can dissipate quickly, water contamination moves according to fixed paths. Once phenol entered the river system, it continued downstream regardless of administrative boundaries or daily routines. The flow of water connected industrial processes directly to kitchens, bathrooms, and households across the city. As reports accumulated, it became clear that the issue was not limited to a single neighborhood or facility. The contamination affected a key element of urban life: water that was assumed to be safe and dependable. What had begun as a technical failure inside an industrial plant was now moving through the city's most essential system, reaching people not through warning signs or restricted zones, but through ordinary taps in their homes. The first clear signs that something was wrong appeared not in official reports, but in everyday routines. In homes across Ufa, people noticed that tap water no longer smelled or tasted as it usually did. The change was sharp and difficult to ignore, especially when water was used for cooking, tea, or washing. For many residents, this was an unfamiliar experience. Water quality issues were not part of daily expectations, and the sudden change immediately raised practical questions. Some stopped using tap water for drinking. Others tried boiling it, hoping the smell would disappear. In many cases, it did not. As similar complaints appeared across different districts, it became clear that the issue was not isolated. The pattern pointed toward a problem affecting the central water supply rather than individual buildings or pipelines. Information spread through personal conversations, workplaces, and local institutions long before it appeared in any official form. Medical facilities began receiving patients with symptoms consistent with chemical exposure. Nausea, headaches, and general discomfort were reported, particularly among those who had consumed tap water before the issue was widely noticed. Doctors focused on stabilizing patients and identifying the likely cause, while also reporting their observations through established channels. Water supply services and sanitary authorities initiated checks at intake and treatment facilities. Samples were taken, and laboratory analysis began to confirm what residents were already experiencing directly. The results indicated the presence of phenol in concentrations far exceeding normal levels. Once confirmed, the situation required immediate coordination. Water distribution schedules were reviewed, and steps were taken to limit further exposure. In some areas, alternative water supplies were arranged, including deliveries by tanker trucks. Residents were advised to avoid using tap water for drinking and food preparation until further notice. These measures, while necessary, disrupted everyday life. Queues formed at water distribution points. Households adjusted routines around limited supplies. Institutions such as schools and hospitals had to reorganize basic operations that depended on clean water. At the same time, specialists worked to track the movement of contaminated water through the river system. Because water flows continuously, the problem could not be stopped instantly. The focus shifted to containment, dilution, and ensuring that incoming water met safety standards before entering the distribution network. Public communication remained brief and practical. Instructions focused on immediate actions rather than detailed explanations. For most residents, understanding came through observation and shared experience rather than formal announcements. As hours turned into days, the city operated in a constrained mode. Life continued, but with heightened attention to something usually taken for granted. Bottled water became essential. Simple activities required planning. The presence of phenol in the water supply had transformed an invisible system into the center of public attention. What stood out was not panic, but adjustment. People adapted quickly, sharing information, resources, and routines. The city responded through existing structures, addressing the problem step by step. The water crisis had become a fact of daily life, and its resolution would depend not on a single action, but on sustained coordination across industrial, environmental, and municipal systems. Once the presence of phenol in the water supply was confirmed, efforts shifted toward containment and gradual recovery. In Ufa, this meant coordinating actions across several systems at once: industrial facilities, water treatment services, environmental monitoring, and public infrastructure. The first priority was to prevent additional contaminated water from entering the municipal supply. Intake operations at the southern water facilities were adjusted, and water flow patterns were reviewed to reduce exposure. Specialists focused on isolating affected sections of the system while maintaining minimum supply for essential services. At the same time, work continued upstream. The discharge pathways at the chemical plant were inspected, and measures were taken to stop any further release of phenol into the wastewater system. Technical teams reviewed operational logs, equipment condition, and process controls to determine how the contamination had occurred and how to prevent its continuation. Water treatment facilities increased monitoring frequency. Samples were taken regularly, tracking phenol concentrations at different points along the river and within the treatment process. Because phenol dissolves easily and moves with the flow of water, improvement depended largely on dilution, controlled intake, and time. Alternative water distribution became a central part of daily life during this period. Tanker trucks delivered water to residential areas, hospitals, and public institutions. Distribution schedules were organized according to demand, and residents adjusted routines to collect water for drinking and cooking. While inconvenient, these measures provided a reliable temporary solution. Public institutions adapted as well. Schools modified schedules, hospitals prioritized critical needs, and food services adjusted preparation methods. These changes were practical rather than dramatic, reflecting an effort to maintain continuity under constrained conditions. Gradually, monitoring data showed improvement. Phenol concentrations in the river and at intake points began to decline as contaminated water moved downstream and cleaner water replaced it. Treatment processes became more effective as incoming levels dropped closer to manageable ranges. As water quality stabilized, restrictions were eased in stages. Residents were informed when tap water could be used again for limited purposes and later for full household use. Each step depended on laboratory confirmation rather than fixed timelines, reinforcing a cautious, measured approach. Throughout this period, attention remained focused on practical outcomes. The goal was not to assign blame or revisit decisions publicly, but to restore normal functioning as efficiently as possible. Existing procedures guided actions, and adjustments were made where gaps had been identified. By the time water quality returned to acceptable standards across the city, daily life had already begun to normalize. Queues disappeared, tanker deliveries were reduced, and household routines slowly returned to their previous patterns. The recovery did not happen all at once. It unfolded through small, confirmed improvements. Clear data replaced uncertainty. What remained was a shared experience of adaptation, a period when water, usually invisible in daily life, required attention and care. The city moved forward not by dramatic change, but by restoring balance within systems that had temporarily been pushed beyond their limits. As water quality stabilized and restrictions were lifted, attention shifted toward documenting what had happened and evaluating its longer-term implications. In Ufa, this process unfolded through administrative, medical, and technical channels that were already part of the city's governance and industrial oversight. Environmental and sanitary services completed a series of follow-up measurements along the river system and within the municipal water network. These assessments confirmed that phenol concentrations had returned to levels considered acceptable for household and drinking use. The data formed the basis for decisions to fully resume normal water supply operations. Medical institutions reviewed cases linked to the incident. Most patients experienced temporary symptoms that resolved once exposure ended. Follow-up observations focused on individuals with higher exposure levels and those with pre-existing health conditions. No evidence of widespread long-term health effects was identified in official records, though continued observation was recommended for certain groups. Technical investigations at the chemical plant concluded with formal reports. These documents outlined the sequence of events that led to the release, identifying weaknesses in process control and wastewater handling. Recommendations emphasized improvements in monitoring, maintenance, and internal safeguards. The focus remained on preventing recurrence rather than assigning public responsibility. Within municipal services, the incident prompted procedural reviews. Water intake protocols were reassessed, particularly regarding early detection of organic pollutants. Sampling frequency and laboratory response times were adjusted to improve sensitivity to changes in water composition before contamination could reach consumers. Public communication summarized the findings in a concise manner. Statements emphasized that the situation had been resolved, that water quality met standards, and that corrective measures had been implemented. Detailed technical explanations remained within professional and administrative domains, while public messaging focused on reassurance and continuity. In everyday life, the incident gradually receded from attention. Households returned to routine water use, and temporary adaptations were no longer necessary. Conversations that had once centered on water quality shifted back to ordinary concerns, reflecting the city's return to normal conditions. Over time, the phenol release became a reference point rather than an ongoing issue. It appeared in reports, internal reviews, and professional discussions about industrial safety and urban infrastructure. For specialists, it served as a case study in how interconnected systems could amplify the impact of localized failures. For residents, memory of the event varied. Some recalled specific inconveniences and adjustments. Others remembered it only as a brief interruption. As with many infrastructure-related incidents, personal experience depended on timing, location, and individual circumstances. The official assessment framed the event as a contained industrial accident with manageable consequences. It did not redefine the city's development path, nor did it alter the fundamental role of industry in the region. Instead, it reinforced the importance of coordination between industrial operations and essential public services. What remained after the reports were filed was a clearer understanding of how quickly everyday systems could be affected by upstream processes. The incident underscored the need for vigilance within complex networks, not as an abstract concern, but as a practical requirement of urban life. With time, the phenol contamination became part of the documented history of Ufa, recorded in reports, measurements, and institutional reviews. It was not remembered as a dramatic turning point, but as a period when a familiar system briefly stopped behaving as expected. Water returned to its usual role in daily life. It flowed from taps again without smell or aftertaste, used without hesitation for cooking, washing, and routine tasks. The adjustments people had made during the restrictions faded quickly, replaced by habits that felt normal and effortless. What lingered was not alarm, but awareness. The incident demonstrated how closely connected everyday life was to processes happening far upstream and largely out of sight. A technical failure at a single facility had moved through rivers, treatment plants, and distribution networks, reaching households without warning or visible signs along the way. This was not unique to one city or one industry. It reflected the nature of complex systems, where reliability depends on many components working as intended at the same time. In later discussions about industrial safety and environmental protection, the event appeared as a practical example rather than a cautionary tale. It illustrated how contamination could move quietly, how detection depended on monitoring rather than visibility, and how response relied on coordination rather than immediate intervention. For those who lived through it, memory was often tied to simple details: the smell of water that seemed wrong, the need to carry containers across courtyards, the temporary pause in routines that usually went unnoticed. These memories did not define the city, but they became part of its shared experience. Industry continued to operate, rivers continued to flow, urban life resumed its steady rhythm. The phrase "dead water" was never an official term, but it captured something intuitive. Water that could no longer be trusted, not because it had disappeared, but because it had changed in ways that were not immediately visible. The incident ended without spectacle. There were no lasting disruptions, no permanent closures, no visible scars on the landscape. Instead, it left behind a quiet understanding that even the most ordinary elements of daily life depend on systems that require constant attention. When those systems fail, the effects can move silently, following paths already built into the environment. History often focuses on moments of sudden collapse or dramatic change. This was not one of those moments. It was a reminder that stability is maintained not by absence of risk, but by continuous care, and that when this balance is briefly lost, life adapts, recovers, and moves forward. The water returned, the city continued, and the incident remained where many such events reside. Not in headlines, but in memory.